Hi, this is Mr. Mack. I'd like to talk to you for a few minutes about vertex form of a quadratic function. Now, the general form for the quadratic function is y is equal to ax squared plus bx plus c. Now, we call this general form. And we can translate this into what we would call vertex form. Now, vertex form is y equals a times x minus h squared plus k. Now, in a times x minus h squared plus k, the vertex is at the point hk. Now, if you look at vertex form of the quadratic function, h, k, and a are actually numbers that tell about transformations that could happen to vertex form. H tells you whether or not the parabola is shifted left or right. K gives you the vertical shift, in other words, whether the parabola is shifted up or down. And then A is going to represent the vertical stretch or compression. Now, first thing to notice is that A in general form, the coefficient of the x squared, and A in vertex form are exactly the same number. So if you have general form and you translate into vertex form, the A's will be the same. Or if you have vertex form and you translate into general form, the A's will be the same. Now, if you have an equation in general form, there are two different ways to translate the equation into vertex form. One method is to complete the square, and the other method is to use the formula h is equal to negative b over 2a. Now, what I'd like to do is I'd like to pick a problem and actually do this thing both ways. So let's start with a fairly simple one. How about y is equal to x squared minus 5x plus 6? And what we'd like to do is we would like to translate this into vertex form. Okay, now, method one, completing the square. So I have y equals x squared minus 5x, and then way over here we're going to put plus 6. Now, since there's a 1 in front of the x squared already, we would like to just go ahead and complete the square. We look at the linear coefficient, which in this case is negative 5, and we take half of. Of means multiply. Half of is 1/2 times negative 5, and we get negative 5 halves. Now we square negative 5 halves, and we get 25 fourths. Now that's what we want to add to complete the square. Now, one of the things you have to remember is that if you have an equation or an expression, you can't just add things. If you do, you get a different equation, and usually we refer to that as the wrong number. Now, in this case, what I'm going to do is I'm going to add 0. In other words, I'm going to go ahead and add the 25 fourths that I want, but I'm also going to subtract 25 fourths. Now, can you see that everything that I have in red here is 0? So basically, I've added 0. Now, we're going to reassociate so that the first 3 terms are associated together, and then the last 2 terms are associated together. Now, we have y equals the first 3 terms. This is genetically engineered to be the square of a binomial, and that binomial is x, the square root of the first term, minus the sine of the middle term, 5 halves the square root of the third term squared. Now, I have to add negative 25 fourths and 6. 6 will become 24 fourths, and so I get negative 1/4. And we're in vertex form. Now, the vertex of this parabola is going to be at the point 5 halves, comma, negative 1/4. Now, method number 2. I'm going to call this the formula method. Okay, we know that h equals negative b over 2a. So, in this case, h will be the opposite of negative 5 over 2 times 1, which is 5 halves. Now, k is equal to the value we get when we put h into the quadratic polynomial. So we get 5 halves squared minus 5 times 5 halves plus 6. Now, 5 halves squared is 25 fourths. 5, let's make that 5 over 1 times 5 halves is 25 halves, and then we have plus 6. Now, I'm going to make all of these fractions have a denominator of 4. 25 fourths minus 50 fourths plus 24 fourths gives me negative 1/4. So notice h is 5 halves and k is negative 1/4 and a is 1. So vertex form, y equals a, that's 1, times the quantity x minus h, minus 5 halves, squared, plus k, that's minus 1/4. Notice we get the same thing either way. Sometimes one method will be easier and sometimes the other method will be easier. Now, let's do one more example, and this time I'm going to choose one that has a coefficient other than 1 in front of the x squared. So let's try y equals negative 3x squared plus 12x minus 7. I don't know where this is going. First of all, let's use the formula method this time. Now for the formula, h is equal to negative 12 over 2 times negative 3. That's negative 12 over negative 6, which is 2. K is going to be equal to negative 3 times 2 squared plus 12 times 2 minus 7. Well, negative 3 times 2 squared is going to be negative 12. 12 times 2 is 24. Negative 12 plus 24 is 12. 12 minus 7 is 5. And a is negative 3. I got that from right there. So the vertex form is y is equal to negative 3 times x minus 2 squared plus 5. Okay, and the vertex, if we need it, is at 2, 5. And it opens downward because a is negative. Now, let's do the completing the square method. For this one's going to be a little more complicated. That's, maybe there shouldn't be an e there. Completing the square. All right, now we have y equals negative 3x squared plus 12x minus 7. Now what I'm going to do here is I need a 1 in front of the x squared. And instead of actually dividing through by negative 3, which I could do, but then I'd have to just multiply back, what I'm going to do is I'm going to factor out a negative 3 from these first two. So I have y equals negative 3, open parentheses. And then you ask yourself, negative 3 times what gives you negative 3x squared? Well, obviously x squared, right? And negative 3 times what gives you positive 12x? Well, negative 4x. Now, I'll leave a space and I'll put minus 7 on the outside over here. Now, since I was writing in red, I have to change colors. What do I want to add in here? I want to add 4. But I can't add 4. All I can do is add 0. So what I'm going to do is I'm going to add 4 and subtract 4 in the same spot. Now, Notice that all of these terms are being multiplied by -3 by the distributive property. So I have y equals -3 times the first three terms plus -3 times -4, and then I have -7 over here. There, that is a 7. I don't know if you can see it. Okay. Now, this trinomial is a perfect square, so we get y equals -3 times x minus 2 quantity squared. Now, -3 times -4 is positive 12. 12 minus 7 is 5. So notice, once again, I get the same vertex form using each of the methods. Now, it is a good idea for you to know both of these methods and choose which one you want to use when it's convenient. And that's pretty much what they're going to expect you to go through. They're going to expect you to graph quadratic functions with transformations. And if they give it to you in general form, you'll be expected to put it in vertex form so that you know what the transformations are. And that is, that's it. We're done.